Okay, let's get started.
Thanks, Yogi. Hello, everyone. Today, I will show the demo of HDFS to S3 app template, which is mostly a reusable app template in big data applications. So before going to the demo, first I will give a brief introduction about Apache Apex. In this, I will cover about what is Apache Apex and what's the architecture and what is an application and how it is a Hadoop native integration. And the next, I will go through the application templates and then AppHub, and then we'll go to the demo. So what is Apache Apex? Apache Apex is a runtime engine and big data platform which enables development of scalable and fault-tolerant big data applications. Apache Apex is a native Hadoop native application, which means that there is no separate service to manage stream processing. Using Apache Apex, we can process streaming as well as batch data. Using Apache Apex, we can create high throughput and low latency applications. And also we have a library of commonly needed business logic, which is called the MapR library. Using Apex, we also write any custom business logic in your application. Now this is the architecture. If you see the bottom layer, we have the Hadoop 2.x. The minimum version to run the Apex is 2.6. So which consists of the yarn and HDFS. And on top of it, we have an Apex core, which is our engine, which takes care of the fault tolerant and low latency applications. On top of it, we have a MapR library, which consists of a bunch of operators like connectors, input and output, and some processing. And also we have a high-level APIs and batch support. On top of it, we have an application templates like Kafka to HDFS, HDFS to HDFS, and file sync JDBC to Kafka applications. These applications we use by using the MapR library. On top of it, the top layer is the DataTorrent tools. So first one is the GUI application assembly. This is for viewing the applications, and management and monitoring tool is for launching and viewing the applications. And also we have a real-time data visualization, which is visualizing the data of the applications. So how do we represent the application in Apex? So application here we are represented as a DAG. It's a directed acyclic graph which consists of the vertices and edges. Vertices we call it as a operators, and edges we call it as a streams. Now what is a stream? A stream is a sequence of data tuples. A tuple is a serialized object, and these streams connects the operator ends. Those ends we call it as a ports. Here, operator takes one or more input streams and performs computation and emits one or more output streams. Here, each operator belongs to the MapR library or user business logic. An operator may have multiple instances that run in parallel. This is the typical application example. So the operators here we categorized into three parts. One is the input adapters, and the next part is the generic operators, and the third one is the output adapters. So the input adapters Either we read the messages from Kafka or read the files from the file system, or it will read the records from the database. And the generic operator will get the tuples from the downstream operator and will do the processing and emit to the next operator. And the output adapter will process it and write to either file system or send it to the Kafka. Here, if you can see, the blue circles represents the input ports and the green circles represents the output ports. Yeah, the next is how the Apex is a native Hadoop integration. Let's take a 4-node cluster, and once you run the Hadoop, one of the resource manager will run it on one of the node. And once you launch the application, the cluster looks like this. If you see here, the green rectangles represents the operators deployed on the containers. Here 1, 2, 3, 4, 5, 6 are the operators are deployed on the containers, and one rectangle represents the STAM. This is a streaming application master. The job of the STAM is monitoring these operator containers. If any of the container goes down, it will redeploy into the different container. And if you observe here, there are different behaviors of these containers. If you see 1 and 2 are on different nodes. And if you see 3 and 5 are the same node. So there's a node local. And if you see 4 and 6 are deployed on the same container, that means container local. This container local, we have two types, like one is the thread local or container local. Here we use the YAML, which is the resource manager, and HDFS used for storing any persistent data. Now, what is the app templates? Here we have observed that most of the applications in production are repeatable patterns. So for these repeatable patterns, we created repeatable patterns for the use cases, and these we are created as application templates. So if you see here, first pattern is like data synchronization or ingestion. Here, if we have the data on HDFS or in Kafka or JDBC or S3, you just move the data to either HDFS or S3. So for this, we have created the app templates. For each, we have created as an app template. And for example, if you want to do some processing like dedupe or enricher, those also we have app templates. So these app templates are ready to use just by importing and launching the applications. So these app templates will exist in one central repository that is called the AppHub. So this is tested and published by the DataTorrent. This is accessible via DataTorrent RTS, or you can directly download from datatorrent.com website. On the right hand side, the picture represents the AppHub. So the main advantages of these app templates is quickly import and launch the application templates. For example, if there is no app templates, you have to create an application and test it, and also you have to do the scalable testing, and then it goes to the production. Here we simply, without all those things, we can just simply we can import it and launch the application by just configuring the parameters. These app templates, if it is not matching your user case, you can easily add your business logic by just adding the custom operators in this app template, and then compile it and import it into the application package. This app templates reduces time to production, because just directly simply by importing and launching the app template, it reduces lots of production drastically here, and also it reduces your cost of operations in production. For these app templates, we have the real-time visualizations like operator metrics and app level metrics. If you want to add any widgets, you can add, simply you can add it. Now let's move on to the app template, that is HDFS to S3. So this is the top level DAG, look like this. So the first one is the HDFS. So the second one is the S3. Here HDFS, we just read the data from HDFS, and S3, it uploads to S3. Here I use the multi-part upload feature. So what is multi-part upload feature? We'll go to the next slide. By using this feature, we'll upload the files into the S3. Yeah, what is multi-part upload? Multi-part upload, instead of uploading a file as a single object, we are uploading a file as a set of bunch parts or blocks, set of blocks. On the right hand side, we can see the picture. Instead of uploading the 1 GB file, we are breaking the 1 GB file into the parts, and then those parts we are uploading to S3, and then finally we are merging that blocks. The advantages of this is, if there is any failure by uploading into S3, we just upload that part. For example, while uploading the third block, if there is any crash happen, we can upload only the third block. And the steps to upload an object into S3 is, the first step is we have to initiate the multi-part upload. By initiating the multi-part upload, S3 returns an upload ID, which is the unique ID to do the complete process. And using that ID, you have to upload the parts in any order, one at a time or in parallel. And once it uploaded all the parts, finally we can complete the upload using the same upload ID and the parts. By uploading these parts, first the S3 returns the E tags. Those E tags we need to pass to the final upload. I shared the link here, so if anyone interested, you can go through the Java code, how to upload a file using multi-part upload feature into S3. Now this we have mapped to our Apex application. Now let's move on to the live demo. Yeah, any questions?
Yeah, before moving into the live demo, if you have any questions, you can type in your questions and we will try to answer them as we go ahead. Yeah, Chaitanya, you can go ahead with the demo.
Yeah. This is our DataTorrent RTS, and on the tab I clicked on AppHub, so we can see the list of app templates available in the central repository. Right now I'm interested on HDFS to S3 sync app. So first we need to click on import. Sorry, there is some network issue. Yeah. Yeah, on the top navigation bar, we can see that application package HDFS to S3 app successfully imported. By clicking on this, it navigates to the app information. There we can see the details of this app, and here we can see the launch and configure. So by clicking on the launch, it opens the configuration dialog box. Here if you can see, the first one is the name of this application. By default it is HDFS to S3 sync. If you want, we can modify this name. And here you have to specify these properties for the application. All these are the operator properties for this application. So the first one is AWS access key, which is needed for accessing the S3, Amazon S3. So for demonstration purpose, I noted those keys. So we have to specify these properties: access key, and the second one is the secret key. And the input directory on HDFS. So from where you want to copy the files. And here the output directory path on S3 storage. So on the S3 where you want to copy these files. So this is the directory name I'm creating. And the next one is S3 storage bucket name. Yeah. And on the down arrow button beside the add, if you can click that, there you can see the add default properties. So these are the default properties for this application template. If you want, we can edit this. So the maximum readers for dynamic partitioning and the minimum readers for dynamic partitioning. So this, what happens is dynamically partition the block readers. So if you make it same, it works as a static partitioning. So for demonstration purpose, I'll specify the value as same so that it works as a static partition. And here what happens is, for the input file, first it splits into the block readers based on the Hadoop, by default, Hadoop block size. So by default, the Hadoop block size is here, it's 128 MB. So for demonstration purpose, I'm changing the default value. So this is the key for that, to change the block size. and I'm specifying the value is 10 MB. So the input file will split into this 10 MB block size. And by clicking the launch, and I want to show one more thing is this input directory. So if you see here in the input, I have a single file of size 4 GB. Yeah, the application is launched successfully. So if you can go to the monitor page, you can see the app. You see the first one, HDFS to S3 sync. By clicking on that, it navigates to the application page. Here we have details like the performance latency in milliseconds and processed per second and emitted per second. So a few of the metrics, we are displaying it here. And once you scroll down, there we can see the logical lag of this operator. So here we have 5 operators. If you can closely look, here there is only 2 modules. One is the HDFS input module, and the remaining operators belongs to the S3 output module. So the first one is the file splitter. It belongs to the HDFS module. So the functionality of the file splitter is it scans the directory, and if any new file forms, it emits the file metadata. And also based on if the default block size is 128 MB. So if the file size is more than 128 MB, it divides into the blocks and those blocks metadata will emit. But here we are specified as 10 MB. So the files will split into the 10 MB block size. And the next operator in this module is the block reader. This is the main operator which reads the data of that block and emits the block data and as well as the block metadata. And as we've seen the steps in uploading the file into the S3 using multi-part upload feature, the first step is the initial upload. So once you get the file metadata, based on the file metadata, we'll create the initiate upload. So by creating the initial upload, S3 will return the upload ID. That upload ID will emit to the block upload and as well as the file merger. The job functionality of the block upload is whatever the block will get, those blocks will upload into the S3. Once you successfully uploaded the blocks into the S3, S3 will return the E tags, and block upload will emit those E tags to the file merger. Here the job functionality of the file merger is to complete the upload. So here we need the list of E tags and as well as the upload ID. If you click on physical, it navigates to the physical operators. So if you can see, here we have so many instances. While configuring, we have specified the maximum readers as 16 and minimum readers is also 16. So the block reader instances is created 16 instances. And all this will do the perform parallel. So here, if you see the file splitter, the number of tuples emitted is 411. The file size is 4 GB and each block size is 10 MB. So totally the number of blocks emitted is 410 and the one is the file metadata. So total is 411. Here we can see that each instance is deployed on which container. Here it specifies the container name. And if you click on the physical DAG view, here we can view the physical DAG. It consists with the instances. So the first one is the file splitter, and the next operator is the block reader. We have specified as 16, so it's created 16 partitions here. And the next one is the block upload. Basically, these two are the container local and partition parallel. That's why if you specify the number of instances block reader is 16, the block upload also is created as 16 partitions. And then finally, it goes to the unifier, and then the unifier will emits to the file merger. Now let's see, we'll do one thing. We'll add one new file into this input directory. So here I'm adding 1 GB file into the input directory. They are successfully added. Now we can see here. So you can see that it started off emitting the block metadata and file metadata. Now what we can do is we'll kill one of the container. So I'm killing this container. So if you can see this 22 ID is redeploying into different container. Previously it is 22. Now it's deployed into 23. Yeah, 23. So that block only it will re-upload into the S3. And these are the few references about the Apache Apex and DataTorrent. So if anyone are interested, please go through these links. And yeah, that's it from my side. So any questions?
Yeah, we will wait for some time. If you have any questions, you can just type in. So in the meantime, we would like to mention that we have job openings at DataTorrent Pune office for backend engineers slash developers, even at senior engineering level or architect level. Requirements for QA and information developer or technical writer, you can say, build and release engineers, and community manager. So if you like this presentation, you can subscribe to our meetup channel where you will get announcements for the meetups, and you can follow our Twitter handle and YouTube channel. On YouTube channel, you will get recordings from all our previous webinars, and we also have a user forum, which is users at Apache apex.apache.org. You can discuss any questions related to Apache Apex on that forum. And if you have any specific questions for DataTorrent proprietary softwares, you can write to dt-users@googlegroups.com. Looks like there are no questions for now, and whatever questions we had in the chat window, we already answered them either by personal message or by public message. So I would like to thank you all for joining us on this webinar, and yeah, hope to see you again on our subsequent webinars. Thank you.